All right, guys, so we just finished up the front page of the quiz review. So that's, we covered multiplication of rationals, division, and then also just simplifying rational expressions. So now we're going to move on to adding and subtracting rational expressions. So here we go. The key to a lot of this stuff is, to factor when it's prudent to do so. With the multiplication division problems, you do it at the beginning. Same thing with simplifying, but with addition and subtraction, you really want to keep everything factored until the end, or at least try to factor, at the end to see if you have anything that you can cancel. So let me show you how that looks. First off, when we're adding and subtracting fractions, remember that you need to find the common denominator. We did a bunch of these problems in 3.3, so if you need some additional help, make sure to check out the video on 3.3 for some extra practice problems with adding and subtracting rational expressions. But it's like adding and subtracting fractions. It's almost identical process. You just need to make sure that you have the common denominator. If you don't, you need to find the common denominator. So for number 7, they already have common denominators, so I don't need to worry about it. But they are subtracting, so that means that I need to subtract all the values individually on the second part here, okay? So here's how it looks. The denominator stays the same, so it's just going to be 15y, but then we combine like terms along the top. So I have x minus x. So x minus x just cancels out, so I don't have any more x values, but then I have 2y minus a negative 5y. When I subtract a negative, it's the same as adding, so that's really saying 2y plus 5y. 2y plus 5y gives me 7y. Now, remember, I don't know, if you watched a couple of the other videos, I said that you can't just cancel out x values here like that unless it's multiplying. Well, here is a case where they are multiplying together. I have 7 times y and 15 times y, so I can just flat out cancel out the y values because they're not adding or subtracting or anything kooky like that. It's just simply multiplying the stuff together. So the y's cancel out, and I'm just left with 7 over 15, and that's my answer for the whole thing, 7 over 15. That's my simplified expression. Number 8, we don't have a common denominator, so we need to get that. So the easy way to do it is just to take this fraction and multiply by this one's denominator, and then vice versa for the other one. So I'm going to multiply at the top and the bottom by 2y. So, and then for this fraction, I'm going to multiply by this one's denominator. So I multiply at the top and the bottom by 2x. So when I'm multiplying fractions, I just multiply straight across. So it's going to be 2y times 3, which is 6y. And then 5x times 2x, which is 10x. These are adding. And then they have the same denominator, which is 2y times 2x, which is going to be 4xy, or 4yx. It doesn't really matter the order that you put it in. So now we're going to try and simplify this as much as possible. And when we simplify, when there's addition or subtraction going on in the numerator or denominator, the best we can do is factor out something from every single term. So the 6y, the 10x, and the 4xy. So what can we cancel out of all of those? What divides out of all of those evenly? Let's take a look. Do any of the variables divide out of every one of them? Let's see, does x divide out of this one? Yes. Yes. But no, there's no x here, so we don't use x. What about y's? Yes, there's a y here, but there's no y here, so that doesn't work. Let's take a look at the coefficients instead. 6, 10, and 4. Is there any number that divides out of all three of those? Yes, 2 does. So I'm going to divide out a 2 from the 6, and I get 3, so 3y. I divide out a 2 from the 10, and I get 5, so 5x. And I divide out a 2 from the 4, and I get 2, so that's going to be 2xy. So this is our simplified expression because I can't simplify it any further than that. Number 9. So number 9, we're again adding. So what we're going to do is find the common denominator here. So we, take this one's denominator and multiply it in the top and the bottom of the other fraction. And then we take this one's denominator and multiply it in the top and the bottom of this fraction. So just make sure that you put parentheses around your factors just to make sure that you distribute evenly and all that kind of stuff. So let's see what we get. In the bottom, it's the same denominator. It's just going to be x minus 5 times 5. Leave it as a factored form because you're going to want to leave it, get it in factored form eventually to simplify it as much as possible. Then for this next one, we distribute in the 4. So 4 times x is 4x. 4 times negative 5 is negative 20. And then we're adding, so plus. And then it's going to be 5 times x, which is 5x. And then 5 times negative 1, which is negative 5. Now let's combine like terms. 4x plus 5x is 9x. Negative 20 minus 5 is negative 25. And then on the bottom, we've got that x minus 5 and 5. Okay, so the only way to divide this 5 out is to make sure that everything divides by 5, which it doesn't, because of this 9 right here, it doesn't divide by 5. And in fact, 9x minus 25 is prime. We can't divide it by anything. We can't factor anything out, so it just is what it is. That's its factor. So obviously, 9x minus 25 doesn't cancel with this x minus 5, so there's nothing we can do. This is our simplified expression. All right, now for number 10, same process. Just multiply by the other one's denominator. So this is going to be n plus 2 over n plus 2. This one's going to be n minus 6 over n minus 6. So let's distribute the 5 in there, distribute the 4 in there, and then we're adding. So let's see what we have. So 5 times n is 5n, 5 times 2 is 10, plus 4 times n is 4n, 4 times negative 6 is negative 24. And then we still have that factored bottom, n plus 2, n minus 6. Do not multiply it in. Leave it factored. All right, so next up, combine like terms. Not 5n plus 4n is 9n. 10 minus 24 is negative 14. Again, two relatively prime values, so we can't do anything with it. And then in the bottom, n plus 2, n minus 6. And since we can't factor the top, this is our simplified expression. That's as good as it gets. All right, so that's adding and subtracting rational expressions. We'll move on to this extra problem over here, number 11. But if you need additional help with adding and subtracting, make sure to go to the video for 3.3 with that.